Okay, we're now going to use what's called L'Hopital's rule, named after some Frenchman called Mr. L'Hopital, or Monsieur L'Hopital. And basically this is a way to work out what's happening when limits are going to inconvenient places. So if we have a look at this expression here, x squared plus x minus 2 over x plus 2, and we can evaluate that at particular values. We can stick in any number we like. We can stick in 1 or 7, any number we like, and it'll work fine, except for x equals negative 2. If we let x equal negative 2, then the bottom line will be 0, and the whole thing will be undefined because you can't divide by 0. So sticking negative 2 in doesn't give us a value, but the question is, what happens as x gets closer and closer and closer to negative 2? So it never actually quite arrives at negative 2, but it gets really close to negative 2. Where's this thing heading? And you could do it by sticking in negative 1.9 and then negative 1.99 and then negative 1.999, and you get a pretty good idea. But there's a better way of doing it, which is L'Hopital's rule, which clearly states that if we have a limit of a fraction, then it's the same as the limit of the derivative of each of the parts. So if we differentiate the top and we differentiate the bottom, it doesn't change the limit. So let's have a go at doing this particular example. So for this one here, this should be equal to exactly the same thing. The limit as x goes to negative 2 of the derivative of the top, which is 2x plus 1, over the derivative of the bottom, which is 1. And now we can substitute x equals negative 2 in without the whole thing dying. So if we substitute x equals negative 2 in, we get 2 lots of negative 2 plus 1 over 1. Negative 2 times 2 is negative 4, plus 1 is negative 3, divided by 1 is negative 3. So as x gets closer and closer to negative 2, this whole expression gets closer and closer to negative 3. It never quite arrives, because you can't have exactly x equals negative 2, but it's heading towards negative 3.